Hey everyone, and welcome! As developers stepping into the Microsoft Dataverse ecosystem, I want you to imagine that you aren't just looking at a standard database. Instead, picture a highly secure, infinitely scalable, state-of-the-art corporate skyscraper. In this explainer, you are the architect and the master builder. We're going to look at how you can construct custom, enterprise-grade logic right on top of this massive platform, using all the precise tools and blueprints that Microsoft provides. Here is our blueprint for this explainer. We'll cover the Dataverse foundation, translate some maker jargon into developer terms, and dig into the security model and granular data control. After that, we'll see how Entra ID automates access, and finally, we'll open up the developer toolkit.
All right, let's dive right in with the golden rule of Dataverse development. As developers, we know code is an incredibly powerful weapon, right? But honestly, here, it should kind of be your last resort. Dataverse includes massive capabilities for configuring custom business logic without writing a single line of code. Your primary job is to write code only to fill the gaps where those standard out-of-the-box features just don't quite give you the exact functionality you need.
So let's start with part one, the Dataverse Foundation, our underlying cloud platform.
Moving right along to part two, speaking the language. Let's translate some of those maker terms into developer terms.
If you've poked around the friendly user interface, you've probably seen things called a table. But for you, writing code in the .NET SDK, that's an entity. Using the Web API, it's an entity type. A column is actually an attribute, and a row is a record. You absolutely need to speak this underlying SDK terminology fluently because, well, the system really doesn't care about the friendly UI jargon when you're communicating directly with its structural metadata.
Which brings us to part three, the security model, and how we protect data integrity.
Welcome to the building's main security checkpoint. Every single data operation your code runs is bound by a user's strict permissions. Think of security roles and privileges as the vital keycards that dictate exactly which floors and rooms your code is legally allowed to enter. A privilege is simply the capability to do something like create, read, write, or delete. But that privilege is paired with an access level. This scales all the way from basic, meaning you can only touch records you own, right up to global, which literally gives you the keys to the entire organization.
These core goals are what lock down data integrity. The system restricts access based on roles, but it also securely supports data sharing for collaboration. And here is why this matters so deeply to us as developers. If you build a synchronous plugin and your code attempts an operation the user doesn't have privileges for, boom, an exception is thrown. You can't just wrap it in a try-catch block and sweep it under the rug. That error is going to roll back the entire database transaction. So you've absolutely got to proactively check user privileges first.
Now, the crucial thing here is understanding the dependencies between these access rights. For example, say your code needs to create a record and automatically make the user the owner of it. You don't just need the create right. Logically, you also need the read right. I mean, you can't own a record you aren't even allowed to see, right? Similarly, assigning a record to someone else requires assign, write, and read access. It's a really intricate, overlapping web of permissions.
All right, part four, granular data control. Let's look at column-level security.
We're moving deeper into the building now. When you secure a column, it gets linked to a field security profile. That profile is then associated with specific system users or teams and finally tied down to field permissions. Those permissions explicitly define if those specific users can create, read, or update that exact piece of data.
Think of securing a column like putting a highly restricted biometric safe inside a room to protect sensitive things like passwords or government IDs. As a developer, you actually have two programmatic ways to unlock those safes. First, you can use field security profiles to grant broad access to a whole group of users for all records. Or second, you can use field sharing. By creating a record in the principal object attribute access table, say that 3 times fast, your code can dynamically grant a specific user access to a secured field on just one single specific row of data.
So how does this evolve? Well, traditionally, if you lacked access to a secured column, the API would literally just return null. But with the new masked data rules preview feature, things get a lot smarter. You can define regular expressions that return obfuscated strings instead. So rather than returning absolutely nothing, an application might see a partially masked credit card number. This lets your app handle sensitive data so much more gracefully.
Moving on to part five, Entra ID integration and automated user access.
If Dataverse is our skyscraper, Microsoft Entra ID is essentially your automated HR onboarding system. The real beauty here is the just-in-time updates. You literally don't have to write custom sync scripts. Step 1, if an Entra ID group is assigned a role, a group team is created in Dataverse just in time. Step 2, when a group member tries to access Dataverse for the very first time. Step 3, the system dynamically adds that user into Dataverse and drops them right into the correct team, entirely at runtime, zero manual intervention required from you. It's fantastic.
And finally, Part 6, the Developer Toolkit. Let's figure out how to choose the right API. Having navigated the terminology and those strict security rules, it's time to actually equip you with your weapons. With all this data sitting securely in Dataverse, how do you decide which API or SDK is the exact right fit for your specific project?
Well, here's your toolbox. If you're writing server-side plugins or custom workflow activities, the SDK for .NET using C# is pretty much mandatory. If you're building a single-page application or using a language that relies on standard HTTP requests, the RESTful OData v4 Web API is going to be your best friend. Now, if you're a data scientist building AI agents or working with Pandas data frames, the new SDK for Python gives you some incredible flexibility. And hey, if you just want to write standard SQL queries, you can connect directly via the tabular data stream endpoint. You've got options.
You now understand the core philosophy, the vocabulary, the intricate security models protecting your data, and the specific APIs at your disposal. You literally have the complete blueprint in your hands. The only question left is, with all these tools, what enterprise skyscraper are you going to build first in Dataverse? Thanks for joining this explainer, and happy coding.